All right, good morning or good afternoon, whatever the case may be. Today we're going to talk about the power problem set. Let me get to a pen that we can use. All right, so this is for the power calculation problem set. We're going to use one of these three equations that I talked about in the lecture series, but this right here is power is equal to current times the change in the potential difference or the voltage. So in all this, P is equal to power. I is current. And we'll use this more in the next chapter that we're going to cover. And delta V is we call it voltage or potential energy. Potential difference, excuse me. I'm just going to abbreviate that. Now for the second one, we're changing Q and T, I, and substituting for Q and T because I'll come up here, I is equal to charge over time. So in this case, we're going to look at power is equal to Q, which is the charge. And we're going to use total charge. I know that the text goes from small to big Q, and T is time. Now, Q times the potential difference is equal to the potential energy. And so that's what PE means. This is potential energy. Now, I'm just going to do one example. I'm going to trust that you guys are smart enough to figure out which equation you need to use based on the variables that you need. And everything's going to use one of these three equations. All right, so looking at example one. How many joules of energy a 850 watt toaster uses in 3 minutes? So we're looking for joules of energy. So PE, we're converting potential energy into work. So they want to know how much, and that's the conversion of energy. 850 watts, that's going to be power, folks. So power is equal to 850. And uses in 3 minutes. So time is 3 minutes. And let's go ahead and convert that to seconds, because time must be in seconds. So 60 times 3, that's 180 seconds. All right, let's look up here. We've got power and time, and we're looking for energy. Power, that's time. So it's one of these two, and potential energy is right here. So the equation we're going to use is that P power is equal to potential energy over time. So I'm going to rewrite my variables. 850 time is equal to 180 seconds. So power is equal to potential energy over time. This is going to be the easiest part of the test. Power P times T, move time over. Remember, this is just one variable. These are two. And all we do is now take 850 times 180. That will give me the PE, which converts to how much is work. So 180 times 850. My potential energy is going to be 153,000 joules. You can say 153 kilojoules, or 1.53 times 10 to the 5th joules. This is normal numbers. This is converting to kilojoules, and this will give you in scientific notation. So those are the three different types you're going to see out there. All right. Thank you, folks.